Hey guys, and welcome to a new video in this C++ tutorial. In the last video we talked about pointers in C++ and like how we can use pointers and what it can be used for. In this video we're going to talk about smart pointers and like why they're smarter than just using the original pointers, as we also like went over a bit about in the previous video. So first of all, like why do we use pointers in C++ and like in programming? Because like in C++ like we're able to use pointers to like point to some memory address in the memory, and then we can do some operations on that memory address instead of like using our variables and copying different kind of data types and like data in our memory. So we use pointers because they can improve the performance of our program significantly. So we can both like improve the performance like memory wise and also like time wise, because it just makes our program more efficient when we're able to like go down in a lower level and like have pointers that is pointing to they're pointing to specific memory addresses in the memory of the computer, and then we can do some operations on those memory addresses instead of that we just like keep copying the data that we're going to use and store and do some different kind of operations on. So like pointers is also like arguably like the most important thing in C++, and like a lot of the reasons like why we should use C++ instead of other programming languages if we really want a like fast and very efficient program, both like memory wise and also like time wise. And it just makes like C++ stand out from other programming languages like Python and Java, where we can like access pointers and actual data, like memory addresses in a memory, and then get down on a really low programming level compared to like some other programming languages like Python and Java, where that is not possible to go down on a lower level. So it's just like really like high and abstract programming language and level. So we can also like, as I talked about, like we can manipulate the data in the computer's memory. Like we're really close to the hardware of the computer, and it's just like another benefit of C++. So yeah, those are like the main reasons why we're using pointers in programming in C++. So we have these smart pointers versus the regular pointers, as we talked about in previous videos, where we just have some pointer that is pointing to a memory address in our computer's memory. But there were some different kind of problems with the normal pointers that we had to take care of in our program ourselves. And one of the problems was that it is not deallocating. It is not like deallocating the pointers when it's done using them, or if we're just using the regular pointers. And in the end, that will cause like memory leaks if we don't like deallocate our pointers or objects like in the right way, or when we're done using them, it will just cause like memory leak, because we can like, for example, like we can remove a pointer that is still like pointing to a memory address, or it can like point to a null address, and then we can't access that data again because the pointer has been removed and it hasn't been deallocated. So we can't access that memory allocation again, which means that we will have some leak in our memory, and in the end it will just like accumulate up, and it will cause our program to crash in the end. So instead of using these regular pointers, we can use smart pointers, which is like built in C++. So smart pointers, they take care of the problems with the normal pointers. So like smart pointers, they automatically manages the memory, and it deallocates the objects when they're not in use, and it also like deallocate memory when pointers go out of scope. So when we have pointers going out of scope, it will just like deallocate the memory, like it will just deallocate the memory where like the pointers are pointing to when they go out of scope, and we don't have to like deallocate them ourselves. It will just do it automatically, and it won't like cause these memory leaks in our program when we're using smart pointers. So we want to use the smart pointers instead of regular pointers in modern C++ programming. So like modern C++ provides the smart pointers here for allocating object and iterators for traversing data structures, and we can also have like something called lambda expressions for passing the functions. So like these are like the main things that we're using pointers for, and specifically in modern C++, we use them for like allocating objects automatically, and iterators for traversing through data structures, and then lambda expressions, which we're going to talk about more in future videos, where we can actually like create our own lambda expressions and functions and do some different kind of stuff with that. So just like when we're using smart pointers, it just makes our program like safer, easier to debug because we don't have these memory leaks, and it's just simpler to understand and maintain. So they're really useful for modern C++ programming. So we have different types of smart pointers that we can use in C++, and all those three here are built in, so we can just like use them in C++. So first one here is the unique pointer, and then we have a share pointer, and then a weak pointer, which are like kind of the same as a share pointer, but I'll talk more about like go more in depth with these pointers here in the next couple of slides here. So the first one here is the unique pointer, and it's like it's the most used and like just the default like smart pointer it is in C++, and it should be used like almost all the time unless you need some of the other pointers and you have a really good reason for it. So the unique pointer here, it holds a pointer to an object and then deletes the object when the unique pointer is deleted, like for example if it goes out of scope, if we just talked about. So, and the unique pointer also like it makes sure that only exactly one copy of an object exists. So we can't like have multiple pointers pointing to one object. If we go down here and see that, like for example here, pointer 1, this unique pointer here is pointing to this object, and then we have a pointer 2, it can't also point to the same object. So we can only have because like our pointer is unique as the name says, so we can only have like exactly one copy of our of the object that exists, and we can only have like one pointer pointing to that object. And if we try to like copy it, it will just throw a compile error and our program will crash. But it can actually be moved to another pointer. So let's say we have like this pointer 1 here, and we want to like move it to pointer 2. So the pointer 2 is now pointing to the object instead of pointer 1. Then we can use the function move. So it really doesn't like copy it, but it just like moves like the pointer from 1 to 2, and then we can use the pointer 2 pointing to the object here as we put it with pointer 1. So that can be used for some different kind of purposes when we're moving between pointers with a unique pointer. And it's just like use it as default unless you like know that you require a share pointer, or like when you're working with share pointers and weak pointers. So you need to like have a specific reason to use the share pointers, because then you have pointers that multiple pointers that are pointing to one object, and you really need to like take care of that, and you need to have a good overview over what's going on, or else it can like cause some like circular waits or like some deadlocks where and stuff like that. So just use it as a default unless you really unless you really know what you're doing and you require a share pointer, because this unique pointer is unique, and it just like it deletes itself when it goes out of scope, and only one pointer can point to one object. So it's a really nice pointer, and it should be used like a lot of times. So we're gonna have this share pointers here, which is it is a reference counting smart pointer that can be used to store and pass a reference beyond the scope of a function. So let's say we have like we need a reference here that needs to be passed beyond the scope of a function. So if we're using unique pointers, we know that when they go out of scope, they will be deallocated. But if we want to use them outside of the scope, we can use the shared pointers here. And we have this reference counting here, and then the reference counting is counting how many like pointers that is pointing to the object, so we can like keep track of like how many pointers are pointing to the actual object. So we can use the shared pointer here when you want to assign one pointer to multiple owners, as we can see down here, that we can have like 2 pointers that is pointing to the same object here, and then the reference count will be 2 here in this case, because we can like have these 2 pointers here pointing to the same object. So share pointers can be useful in object-oriented programming, which we're also going to talk about in later videos. And like object-oriented programming is a really important topic inside of modern programming, and also like C++. So we're definitely going to cover that in a lot of different kind of videos later on. But it can be useful in object-oriented programming to store a pointer as a member variable for that object or like class that we made, and then return it to access the reference value outside the scope of the class. So that can be like very useful in some different kind of cases, and we're going to see we're probably going to see some examples with them when we're going to talk about like object-oriented programming. And the shared pointer is not deleted until all owners have gone out of scope or have given up the ownership for the object. So we could have like actually like still have pointers that are not deleted, or like owners of that like object or pointer, and it will still be deleted because like the owner has given up its ownership to that object. Then we can also like use weak pointers if we're using like shared pointers in different kind of special cases. So the special case here for the weak pointers is that it can be used for shared pointers in special cases, because like it provides access to an object that is owned by one or more shared pointer instances, but it is not part of reference counting. So it won't like count how many pointers that is pointing to the object here. So in the example down here, the reference count here will not be maintained for the weak pointers. So we don't know like how many weak pointers that is pointing to that reference, like, because it is not part of the reference counting. So we can use it when you want to like observe an object but not require it to remain alive. So we don't really care about if it's alive or not. We can just use the weak pointers to observe an object if you want to like observe some different kind of information and stuff like that. But we don't really care if it remains alive or if it goes out of scope, or it will be deleted at some point. Then we can use weak pointers together with the shared pointers that we talked about in the previous slide. It also like required. It is also like required in some cases to break a circle of references between shared pointers instances. So we can have like these references between the shared pointer instances where we have these pointers that is pointing to like multiple pointers are pointing to one object, and we can like it could like cause some like circular reference between like those shared pointer instances, and then we can use weak pointers to like break that circular reference between those different shared pointers. So let's jump into Sublime Text here. I'm going to show you some examples on like how we can use the smart pointers in C++, because we just like import a library and they're already built into C++, but we need to like know how to use them and set them up, and like what different kind of situations they can be used. So we're now jumping into Sublime Text here, and I'm going to show you some different kind of examples with those three smart pointers that we've just talked about in the slides. So first of all, we're just going to include the memory library up here, which contains the smart pointers that we're going to use. And then we're creating a class here where we're going to have like pointers that is like storing objects from the rectangle class here. So we have this length and the breadth of the rectangle here, and then we just have one method in our class here, which is called area. First of all, we have our constructor here, where so like every time we create a new object of the rectangle class here, it will be initialized with these two parameters here, which is the length and the breadth. And then we have this function here that just returns the area of that rectangle, which is length times breadth. So we're gonna go down here to our main function. We can see that the first examples here are like how we can use unique pointers in C++ and like store unique pointers to those rectangles that we create of the class here. So first of all, we can use this unique pointer here, and then we can store like rectangles, like, or have like unique pointers pointing to rectangles here, with this type of code line here. And then we create an object here of the rectangle class here, or like the pointer. So this is the pointer, first unique pointer here, and then we create a new object here of the rectangle class here. So we give it the length 4 and the breadth 5. And then we have now stored this object here in the unique pointer p1 here. So if first of all we just print out the array here, like we can access when we have a pointer to like the rectangle, or if we have created an object pointer, then we can use this arrow operator here. So to access this function here inside of the object here, or the class rectangle class here, when we have the pointer, we can just use this arrow operator here to access this function. So if I hit Control B here, you can see that it will print out the area of the first rectangle here, which is 4 times 5. So it will indeed print out 20 in this case here. So if we go down here and try to use this, we create a new pointer here, P2, and then we want to have it pointing to P1 here. But as we just talked about in the slides, when we have a unique pointer, only like one pointer can point to one object. So in this case here, we can't have this unique pointer pointing to the same object as P1 here. So this will throw a compiler error if I run the code here in this case here, because we can't create multiple instances of have multiple pointers that are pointing to the same object when we're using unique pointers, because they're unique as the name says. But we can use this move function here. So if we created a unique pointer here with rectangles and we call it P2, then we can use this move function here. So we move the first pointer here to the second pointer, and then we can go down here and see that now it will actually work, and we have now P2 pointing to this object up here, which was like originally pointed to by the P1 pointer, a unique pointer here. So if we print this out here now, we can see that it will also print out 20, and it will just be the same as up here with the P1, but we have now moved P1 to P2. And if we print out the error here for P1 as well, we can see that it won't like return anything. It will just throw an error here because now P1 is not pointing to anything, because and it will be deleted because now we move the object from the first pointer to the second pointer. So it will just throw a compiler error if you try to do that because P1 is not pointing to anything, and it's like not pointing to this object anymore. So if we're going to use shared pointers, I have a couple of examples here with shared pointers as well, where we're still going to use this rectangle class. So the shared pointer here is where we can have like multiple pointers pointing to the same object, because we have this shared pointer here. And create a new pointer here, P3, with this object here, rectangle with the length 2 and the breadth 6. So if we see out the area of this P3 here, we can see that now it will be 12 because 2 times 6 is indeed 12. But here we can have the shared pointer here, and we can do the same as like up here, where we can now actually like we can have multiple pointers pointing to the same object that we have created up here of the rectangle. So now we can actually like create a new rectangle shared pointer here called P4, and then we can actually just set P4 equal to P3. And if we print these out here, we can see that both will actually, like, I'll just comment this out here. We can see that they're both outputting like 12 because both pointers are pointing to the same object, rectangle object up here. Because when we have shared pointers, like multiple pointers can point to the same object. So in this case here, we can see that it works for shared pointers, and this is like the idea for working with shared pointers instead of unique pointers. But if you don't have like a really good reason to use these shared pointers, you should just use like unique pointers. And if you want to like change them between different kind of pointers for some applications, like in some cases, you just use the move function instead, and then you're only working with one unique, like one shared pointer or like one pointer, and it just gives you a better overview or like what's going on, and it's also easier to debug if something goes wrong. So we can also use this function down here, the P3 and this use count function here. And if you hit Control B, it will print out 2 because the reference count is 2, because now we have like two shared pointers that is pointing to the same object. So the use count here will be 2. And also if you just hit P4 here, it will still print out 2 because we still have two pointers pointing to the same object. So we can use this function here, use count, to keep track of like how many pointers or shared pointers that is pointing to the same object. So the last example here I'm going to show you is like weak pointers, like how we can use weak pointers together with shared pointers. And we're going to use this rectangle object up here again, where we create a new object with the length 2 and the breadth 3. And we have this shared pointer here called P5, and it just like points to this new rectangle object here we have created. And then we can create a weak pointer here. We just call it WP1, and we have another weak pointer here, WP2, and that will like point to the same object as the WP1. So we just like have this pointer pointing to multiple objects. And then down here and in the third initialization here, we have this weak pointer 3 here, and that will point to the same as the shared pointer P5 here. So then we can use this weak pointer here. So if you see out down here, we can see like what the weak pointer does, and we can see that the use count here for the weak pointer is that when we're using those weak pointers down here and store them, and then when they're pointing to each other, like we don't keep track of like how many pointers are pointing to that object. And we can see that the third one it prints out here, it will now print out 1 because we have this shared pointer here P5. which has a use count of 1. So if for this weak pointer, the third weak pointer here, it will print out 1, because now we have like 1 pointer, and it will be the share pointer here pointing to this rectangle object up here. So, and then we can like use these weak pointers here, as we talked about in the slides, for some different kind of purposes when we are like operating or dealing with object-oriented programming, and we want to like have these like where we have like circular references between a shared pointer, instances or like references. So that's it for this video, guys. We've been over like the different kind of types of smart pointers in C++, and like how we can use them together with object-oriented programming and classes, and like in what different kind of situations like we can use the different types of smart pointers. And like just to like round it off, like we normally just use like this unique pointer, and it's really good, and we should like use the unique pointer instead of like the regular or like raw pointers in C++. So this is like more a modern way of writing C++ code. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification on the video, and also like this video if you like the content and you want more of it in the future. If you want to use this stuff you learn in C++ here for some other different kind of like practical examples, or like some other topics, like I'm also doing this computer vision tutorial in C++ with OpenCV, and also an algorithm and data structures tutorial in C++. So if you're interested in one of those, I'll link to one of them up here, and you can go try out your C++ skills that you have learned here, or else I'll just see you in the next video, guys. Bye for now.